Hey everybody, in this video we are going to get ready to work with inverses in a more pre-calculus sense using trigonometry, but to warm up we are just going to revisit inverses in a more algebraic sense using some parent functions that we should be pretty familiar with as we just reviewed graphing them. So let's get started. So what do we remember about inverses? Most people tend to remember when it comes to inverses that algebraically you switch the x and the y to start, and then you solve for y. A lot of people remember that. Now, we're going to do that, but we don't have y explicitly laid out for us, but we do have f of x. So if we just kind of rethink of f of x as y, because, it is our output, so all good, we can go ahead and switch our x and y and solve for y. So here is my original equation. And when I switch x and y, my inverse, I'm going to use blue now. So I'm going to have x equals 2 cubed root of y minus 1 plus 5. And now I'm going to find the y value. I'm going to get y alone. Now, before I do though, what is an inverse operation and what is an inverse equation? An inverse operation is what we're going to do step by step right now to get y by itself. For example, we're going to subtract 5 because subtraction is the inverse operation of addition, right? So we have x minus 5 now equals 2 times the cubed root of y minus 1. So those are inverse operations. So we're going to divide by 2 or multiply by 1/2 next. And then we're going to cube both sides because, again, another inverse operation, cubing is to a cube root. We're going to add 1 and so on. An inverse equation is basically a compilation of a bunch of inverse operations. And as an equation, it will undo everything in the other equation, just like an inverse operation will undo another operation. All right, so anyhow, from here, instead of dividing by 2, I am going to write it as times 1/2 because it's going to help us a little bit in the styling for when we are going to do some graphing in a following step. After this, I'm going to cube both sides, so it's going to be on the outside of that 1/2. So the cube root and the cube are going to get rid of each other. So I'm just going to rearrange this a bit. That means I have y minus 1 on one side. And then I have 1/2 times the quantity of x minus 5, all raised to the third. And then to finish it up, I'm going to add 1 to the other side. So that's gone, and I will have plus 1 right over there. And then I'm just going to really exaggerate that parenthesis right there so that we can see clearly. Okay, so right now, what do I have? And I'm going to erase over here. Where's this eraser? That, just so it's a little bit cleaner. And I have that y equals that right there, and that is the inverse. And it's really the inverse equation. All right. So there we go. So initially I had this equation right here. That was my original equation, which I called f of x. Now when something is called f of x, g of x, h of x, it's named like that. That means it is a function. It passes the vertical line test. I'm not naming my inverse f of x, g of x, or maybe you're familiar with f inverse x yet, because I don't know if it's a function yet. I mean, maybe you know, but we're going to pretend we don't. So found the inverse algebraically, we did a little discussing, visually analyze, graph both f of x and the inverse of f of x, we will call it y for now, on the plane above. So we're going to do that right now. So I'm going to start off with red, and I have a cube root graph. We should all remember that the cube root graph has a bit of this shape to it. You should know the pattern that it really follows because of all the practice we did. I'm going to shift to the right 1 unit. Because of the minus 1, I'm going to go up 5 because of that plus 5. 1, 2, 3, 4, and 5. That will be my point of inflection. The 2 is a vertical stretch of 2. So instead of going up 1 over 1, up 1 over 2, 4, 6, 7, and then down 1 over 1, and then down 1 over 2, 4, 6, 7. So really, if I did not have that stretch, I would follow these dots right there. Instead of doing that, I have that vertical stretch of 2. So I'm really going to go up 2 over 1. So this is the real dot. Up 2 over 7. There's another more real dot right there. And same down 2 over 1 in that direction. Down 2 over 7 that way. And it will look like this right over there. So that is the original function we were given to start. And now my blue one, that is a cubic graph. And hopefully we all remember that the shape of a cubic graph is more or less like this. And it follows that same pattern where 1 cubed is 1 and 2 cubed is 8. So it's 7 units more than 1. Now I'm going to go to the right 5 for this guy. 1, 2, 3, 4, 5. Up 1, because of those are my shifts. And then the 1/2, that's inside of the function, right? And it's in the backward house. So that 1/2 is actually a horizontal stretch of 2. So while my original had a vertical stretch of 2, right? My new guy has a horizontal stretch of 2. So instead of over 1, up 1, and then over 1 and up 2, 4, 6, 7, I'm going to go horizontal stretch. So over 2, up 1, over 2, up 7. So I will have that piece there, which I can't really see the arrow, sorry. And then left 2, down 1. Left 2, down 2, 4, 6, 7, and so on. For more help with graphing, you got to go check out one of the other graphing videos. This is not the time. Now, just going to accentuate the little crosshair. That's sort of my HK, where I calibrated my new center. Now you should notice symmetry over this dotted line, and the equation of this dotted line should be familiar to everyone. It is y equals x. It is the identity function. It's the parent function for a linear equation, and it's where y and x are equal to each other, 0, 0, 1, 1, 2, 2, and so on and so forth, right? Now, does f of x, which is red, pass the vertical line test? Of course, right? We already know it's a function because, well, it was called f of x. Does it pass this? What the heck is HLT? That would be the horizontal line test. Does it also pass a 1 slice through on the horizontal line test? And in this case, the answer to that question is also going to be an emphatic yes. If yes to both, then we say that f of x is 1 to 1. So no x's and y's are essentially cheating on each other. They're all being loyal to one another. That means if a function is 1 to 1, that tells me that its inverse, which is reflected over this y equals x line, this folded and flipped around little guy, its inverse is going to also be a function, because if this passes the horizontal line test, the inverse will pass the vertical line test. So if you know a function is 1 to 1, then you essentially know that the inverse will be a function. So is the inverse equation a function? In this case, yes. If yes, we can call it f inverse of x, and we call that like that, f inverse of x, because it is indeed an inverse function. So this y right here, I can go ahead and erase, and I could rename if I want to, or refer to it out loud this way. And we like to do this because it's telling you where it came from. It's like using a last name, like you know which family you belonged with, right? That you are going to, report to. So there you go, f inverse of x. Now, let's chat a little bit about domain and range. So the domain, and now this example is not too wild. For the cube root function, that looks like this. The domain is from -infinity to infinity. And my range, bottom to top, is also -infinity to infinity. When we find an inverse, the domain and range, when we switch x and y, are essentially trading places. So this over here, the range, becomes the domain of my inverse, and vice versa, or similarly, the domain becomes the range of the inverse. So both of them are all real numbers, a little anticlimactic. Now, one last thing, when you have a function and its inverse and we compose them together, That means I'm going to take 2 cubed root of, now what was it? I already forgot. X minus 1 and then plus 5. So x minus 1, and then on the side, plus 5. And in here, where x would go, I'm going to fill in the inverse, f inverse of x. So again, let's just, with the highlighter, be a little bit more specific. So I have f on the outside. That is the red, essentially the red function over here. And then on the inside, we're going to fill in the inverse wherever the x was. We're going to plop in my inverse. So that would be, I already forgot, we had a 1/2. We had, I don't want to mess up anything, x minus 5. And then plus 1. All right, now that's all set up for us. What can I do to start cleaning this up? Well, for starters, the minus 1 and the plus 1, those are kind of free for me to get into, and they're gone from each other, right? Now, next up, let me just exaggerate these parentheses a bit, make them a bit more noticeable. So next, we can't just go all willy-nilly in any order we want, but next, the cube, right, and the cube and the cube root are going to, well, be inverse operations and undo each other. So what do I have next? Well, let me clean this up a bit. I have 2 parenthesis 1/2 parenthesis x minus 5 close plus 5. Well, what else can I tackle right now? Well, the 2 and the 1/2. And then lastly, after that, I can deal with the minus 5 and the plus 5. And my final answer is x. When you compose a function with its inverse, you will get just x. Now, you can try this one yourself, and you should get the same answer. So, good luck with that. All right, set that up. And basically, you should get x again. Make sure you set it up correctly. I will just get you started a little bit. So, your outer function right here. And that's going to equal and then something like this. And then that will go inside. And I'm just going to set up a little bit. So we will have this. And I'm doing too much. All right, something like that. On your mark, get set, you finish the rest. And check out the next video, example 2. We'll see a different scenario. That's the end of this one. Hopefully this is all good, coming back to you. You're remembering a good amount. If so, thumbs up. If not, thumbs down. And adios for now.